Hello people, today we are going to take a topic of aptitude as well as basic physics, which is physics of light. So what are we going to see today is, you must have observed that an object appears red or blue or maybe any color when you see it in white light. White light means sunlight, that is the light we have around us. But if you wear a lens of different color or you use a cellophane and see through it, the object appears of some different color. Today we are going to know how this happens and why it happens. As you all must have learned, there are three basic colors of light, which are red, green and blue. These are also known as primary colors. All the colors that you see in the television, on your television set, are also made of these colors. They are only using three colors, red, green and blue, and all the other colors that you see are combination of these colors. RGB, you must have heard. RGB are the three primary colors. So if you combine any two of these primary colors, you get a secondary color. Like if you are combining red and green, you get yellow color. Similarly, if you are combining red and blue, you get a magenta color. This is how magenta looks like. You can see here. If you combine blue and green, you get cyan color. This is cyan color here. Okay, and if you combine all these three primary colors, that is, you combine red, green and blue, you get white light. And if there is no color, that is, there is no red, no green or no blue, we have black color. Okay, so this is how you add lights. That means if you are having red light and green light from the same source, it will appear as yellow light. But in the case of paints, in the case of colors, it is different. Lights are additive, colors or paints are subtractive. What does this mean? In case of paints, the three primary colors are yellow, magenta and cyan, which are secondary lights in case of lights. So if you subtract yellow and magenta, you get red color. How is this happening? Let's have a look. Yellow, see here, yellow is made of red and green, and magenta is made of red and blue. As you see, in both of this, only red is common. So we are getting, if we are adding yellow and magenta, we are getting red. One thing you can observe here is, here we are having OR operation, and here we are having AND operation. And operation means common to both, only that will come in the result. OR operation means even if you are having one color and you are having one color, both will come in the result. Okay, here also you can see, in yellow and cyan, only green is common. Yellow and cyan, see, green is common. Therefore, when you are adding yellow and cyan paint, you are getting green paint. Similarly, on adding cyan and magenta, you are getting blue paint. So what we learned from here is, lights are additive and paints or colors are subtractive. This is the reason when you add all the three primary paints, you are getting black color, because in all the three colors you have RGB all common. If you add yellow, magenta and cyan, you will have RGB all the three colors, and when RGB all the three colors are combined, you get black color. Okay, so now, do you know why a red object appears red to you in white light? For example, an object appears red if it reflects red light. Okay, so if you see an object as blue, it is appearing blue because it reflects blue light and absorbs all the other lights. So if I say an object to me appears green, that means it is reflecting green light and it absorbs red and blue lights. Fine. So here are some questions. Let us have a look. See, green plus magenta. What colors is magenta having? Red and blue. So basically they are asking green, red plus blue, which we know is white. Try to solve all the questions in terms of primary colors. It will be easy. So we know yellow. Yellow is combination of red and green. Already red is given, so answer is green. Then red plus blue. Red plus blue are the red and blue are primary colors. What color are we getting? Magenta. Okay. Cyan. Cyan is a combination of blue and green. So answer is green. Yellow plus blue. Yellow already is a combination of red and green. And we are adding blue, so we get white. Magenta. Magenta is a combination of red and blue. And we want white. That means we need to add green. Okay. Now we want white. White means red plus blue plus green. We have red, so we need to add blue plus green. Blue plus green is cyan. Here also we need white. That means we need red plus blue plus green. Already we have red and green, so we need to add blue. Okay. Now see, the rose is red. Already it is red. Okay. And we are giving it green light. See, if the rose is red, it is supposed to reflect red light. And what is it going to absorb? The other two primary colors, which are blue and green light. Since we shine upon it green light, it is going to absorb. This red rose is going to absorb the green light, and so it will appear black. If an object is not reflecting anything, if it absorbs everything, it appears black to us. And if an object reflects everything, it appears white. So this red rose will appear black in green light. Okay. Now look at the next question. A piece of red cloth appears red in white light because it absorbs blue and green and reflects only red. Let us take a look at our next concept, which is complementary colors. What are complementary colors? Complementary colors are the two colors which when added produces white light. Okay, so you can write two colors are said to be complementary to each other if their addition produces white. Okay, let us take up some examples. Red plus cyan is white. We know this. So complementary color to red is cyan. Similarly, green plus magenta is also white. So complementary color of green is magenta and complementary color of magenta is green. Also blue plus yellow is white. So we can say that blue and yellow form a pair of complementary colors. Now let us look at some more questions related to the same topic. So we have a green shirt. A green shirt is observed in blue light. Okay, so let us first just quickly see, if a shirt is green, what colors is it going to reflect? It is going to reflect green light. And what colors is it going to absorb? It is going to absorb red and blue lights. Now see, what light are we giving it? We are giving it blue light. Only blue light is there, and it is given to green shirt. It is going to be absorbed. So what color it will appear to be? It will appear to be black in color. And you know the reason, because blue light is going to be absorbed. If all the light is absorbed and nothing is reflected, the object appears black. Okay, now see next question. Daylight means white light. White light has all the three primary lights, that is red light, green light and blue lights. Okay, in daylight an object is appearing red, and if it is seen through a red glass. Okay, the object is appearing red when it is seen through a red glass, and it appears black when seen through a blue glass. Okay, if the object is appearing red when seen through a red glass, that is, it is reflecting red light. The object is reflecting red light, then possibility is that the object may be red colored, maybe yellow colored, because yellow has red and green both, right? Or magenta, because magenta is also having red and blue. But see, it is appearing black when seen through blue glass. If the object were magenta colored, it should have appeared blue when seen through a blue glass, but it appeared black. That means it is not magenta. It is either red or yellow. If an object is red or yellow, it will appear red when seen through a red glass, and it will appear black when seen through a blue glass. Okay, next question. We've already seen this question, but again it is given. Let us see. Write the names of pair of colors which combine to give white light. And what is the name given to such a pair of colors? We've already seen such colors are called complementary colors. Complementary colors are those which when added give white light. We've also seen the examples, so no need to do it again. Okay, come on, the next question. A flag is made up of 3 strips of cloth of yellow, white and cyan colors. Okay, name the color of a particular light in which the flag will appear to be of single color. Okay, see this. What colors is yellow made up of? Quickly recap. Yellow is made up of red and green. Then white. White is having red, green and blue. And cyan. Cyan is having blue and green. So now we want a particular light with, so that this flag will appear to be of a single color. Okay, see in all the 3 strips, yellow, white and cyan, only one color is common, green. Here also green. So if I shine green light on this flag, all the 3 colors are going to reflect only green. If you shine any other light, it will not appear to be of same color. So the answer is green light. Okay, come on, the next question. White light is passed through a yellow filter. What colors is white light having? First let us see. Red, green, blue. Okay, fine. So now it is passed through a yellow filter. If this is passed through a yellow filter, only yellow light is going to go further. So only yellow comes further. Yellow means red and green. What colors are seen on a screen plated at the end? So colors which are going to be seen are yellow, or you can say red and green. Fine. Now the light emerging from the yellow filter is again passed through a red filter. If it is passed through a red filter, what colors are going to go further? Only red. So what will be seen on the screen placed at further end? Red. Only red is going to appear further. Okay, let us move on to the next question. A room has window panes made of a special glass which can reflect green light, transmit red light, scatter blue light and absorb all the other colors of light. Okay, one more thing. If this is a plane surface, this is a plane, okay, and you are giving it a light, or you are giving it a ray maybe, there can be three phenomena. There are three possible phenomena. It can reflect, it can transmit, or it can absorb. Okay, reflect, this is a reflection. Reflection means the same light is transmitted back. Transmit means it lets it go through it and travel further. And absorption is this ray terminates here, this ray terminates at this surface. Okay, now look at this question. The window panes of this room are such that it reflects green light. That means this green light is going to remain inside the room. Transmit red light. Red light is going to go outside the window, outside the room. Scatter blue light. Scattering is another process, but in scattering, this light is not going to be transmitted, it is going to stay inside the room. Okay, and all the other colors are absorbed. Fine, so they are not going to stay inside the room, and neither are they going to go outside the room. Fine, so this is eliminated with white light from the inside. White light is having red, green and blue. Okay, so the question is, what color will the window pane appear when seen from inside the room? So which all lights are inside? Inside. See, green light is inside. Then red light is outside, it's gone. Blue light is inside. So what light will appear from inside the room? Green and blue. Green and blue make cyan. So answer is cyan. Outside the room, only one light is going out, which is red. So it will appear red room. Some special room appearing cyan from inside, red from outside. Okay. Moving on, come to the next question. What will the color of a blue flower when it is seen in magenta colored light? Okay. See what colors is magenta having? Red and blue. Okay. This is a blue flower. What lights is it going to reflect? Only blue. Only blue is going to be reflected, and all the other lights will be absorbed. This magenta colored light is having red light and blue light. Luckily blue light is there. Blue light will be reflected. So this flower will appear blue. Blue is the answer. Fine. See the next part. Name another secondary color of light in which the flower will show the same color as it shows in the magenta colored light. What is the meaning of this question? This means we want to see the flower as blue only. Okay, but we want to give it some other light. Okay, now let's see what all secondary colors are having blue. Magenta is having blue, cyan is having blue, yellow is not having blue. Fine, magenta we have already given. It is asking for another secondary color of light. So this is the answer. Answer is cyan. Okay. Let's look at the last question. What will be the color of an object which appears green in white light and black in red light? Okay, always remember, in white light all the objects show their true color. Why this is happening is because in white light all the three primary lights are present, red, green, blue, all the three are present. So whatever be the color of the object, it will reflect the same light and will show their true colors. So if an object is appearing green in white light, then its actual color is green only. Okay, actual color is green. If the actual color is green, obviously it will appear black in red light. So always remember, an object shows its true color in white light. Okay, hope this lecture will be helpful to you. Thank you.